Ethanol is an extremely useful solvent both for polar and nonpolar compounds. The hydroxyl group makes the molecule very polar, allowing it to dissolve polar substances, and the ethyl part of ethanol is nonpolar, allowing ethanol to dissolve nonpolar substances. Because of this, ethanol is one of the most useful solvents. I found my ethanol in the form of ethyl rubbing alcohol from my local store. Unfortunately, it is also the active ingredient in alcoholic beverages, and thus it is a controlled substance. This means that whenever you purchase ethanol for use as a substance, for example, you're most likely going to find denaturing agents mixed with it. These denaturing agents usually consist of a bitter substance like denatonium benzoate and a noxious substance like acetone. These substances are usually easy to remove by distillation. The main steps in purifying ethanol rubbing alcohol is to first get rid of the water and then to get rid of the denaturing agents. In order to do this, I will be using molecular sieves to pull the water out of the mixture and then performing a fractional distillation. First, I started by pouring my rubbing alcohol into a liter beaker, as I wasn't really sure how much I had. I figured that it was probably less than 1 liter, so I'd be safe. I then added a bunch of molecular sieves. Normally they are supposed to absorb about half their weight in water, so I probably added way too many. However, they're so easy to regenerate that I wasn't entirely upset about this at all. I left this mixture out for about a day, and when I came back, the bubbles had significantly died down. At this point, I had two options. I could either filter out the sieves or just distill the entire mixture. I was feeling kinda lazy, so I wanted to just distill the entire thing, but unfortunately, my round bottom flask was not big enough to handle this. Because of this, I decided I would have to filter the mixture. In order to filter it off, I set up my vacuum filter funnel on top of a random Erlenmeyer flask I found. I then poured all the contents of the beaker into the funnel, and luckily it all fit. If it didn't, I could have of course done 2 runs easily, but I currently only have a manual vacuum pump, so I didn't really want to. After filtering it, I transferred everything back over to my original 1-liter beaker. I decided after this to measure the concentration using a hydrometer specifically calibrated to ethanol. As you can see, when I put the hydrometer in a measuring tube and fill it with ethanol mixture, it reads about 79 or 80% ethanol. This is about what I was expecting, and thus I incorrectly assumed that the water was pretty much completely gone. The next step in this process was to do the actual distillation. I originally set up for a simple distillation, but last minute I decided I'd actually do a fractional one because acetone and ethanol's boiling points are less than 30 degrees apart from each other. However, I probably could have used a simple distillation, but I think a fractional one would have been much safer. After I got all the glassware put together, I'd added the now filtered and now water-free ethanol, acetone, and other crap mixture and plopped in a stir bar. I turned on really strong stirring and then decided that I probably didn't need it to be super strong, so I turned it back down a bit. Then, with a lot of struggling, I attached the tubes to my condenser and started the water circulation. After all of this, I turned on the heat and waited for it to start boiling. Eventually, a solvent front can be observed going up the Vigoro column and around the still head. This is always one of my favorite parts in any distillation. This Vigoro column is the fractional column in the setup, and it plays a somewhat important role. When you boil a mixture, the lower temperature liquid boils off first, and due to the laws of thermodynamics, the temperature of the mixture doesn't really change. Normally, a simple distillation would work based on this principle, but when the difference between the two liquids' temperatures decrease, some of the less volatile liquid starts co-distilling off with the lower boiling point one. The Vigoro column essentially allows the liquid mixture to have more chances to condense, and at each point of condensation, the more volatile liquid revaporizes and the less volatile liquid condenses back into the flask. At the top of the column, we should be left with only the more volatile liquid, which in this case was acetone. This mixture certainly does contain acetone, and so I jerry-rigged an acetone collection beaker. Up until around 78 degrees Celsius, I can assume that the condensate contains acetone in it. This is still useful to me though, because I can still use it as a semi-pure acetone, or I can use it to clean or dry glassware. Because of this, I actually decided to keep the acetone waste. Once the temperature on the thermometer hits about 78 degrees Celsius, I, with a small amount of difficulty, replace the waste container with a round-bottom liter flask to collect my ethanol. Normally, I would collect until the temperature rises way above 80 to about 120, but as you will see later, there was a slight issue which caused me to stop early. When a liquid is heated in the heating mantle, it can be subjected to bumping, which is when the bottom liquid is the only portion that can boil, so it builds up and then all at once bumps the entire apparatus. This is dangerous not only because you can break the apparatus apart, but it can spill over into the collection flask. As you can see, when I turn off the stir and wait a little bit, the mixture bumps quite a bit. Because of this, it is important to either have always a stir or boiling stones in your mixture when you boil it. After about 20 minutes or so into the distillation, I ran into a slight problem. I noticed that there was a vapor building up on the side of the end of the still adapter, and there was a hot vapor coming out of the gas outlet. This was a big issue because it meant that efficient condensation was not happening and that I was losing ethanol. I quickly looked and saw that the condenser was only half full and that the water pump had actually stopped working. I quickly struggled a little bit to reconnect the pump and unkink the pipe attached to the water input. Thankfully, I was able to fix this, but at this point, I kinda didn't want to continue with the distillation. So at this point, I decided to stop heating and waited for it to cool down a little bit. At this point, I was getting slightly impatient as I had just burned my hand and lost a significant portion of my ethanol. I decided that I would replace the collection flask with a waste container again, and the rest I would distill at a different time. At the end of the distillation, I was left with what I thought was relatively pure ethanol. Using the hydrometer again, I poured my new ethanol into a measuring tube. Unfortunately, I didn't have actually enough to do the reading with it, so I decided to add some of my other confirmed anhydrous ethanol that I had made previously. Unfortunately, right off the bat as I pour it in, you can see that the two liquids have different densities, and at this point I mostly figured that the water was not all separated as the acetone stench was basically completely gone and nothing else in the mixture had a boiling point lower than ethanol or acetone. Once I filled up the tube, my suspicions were confirmed as the ethanol only read to be about 96%. I decided that this was pretty much good enough for what I was using it for, and I relabeled the container I was using previously. After that, I expertly funneled it into the new ethanol and tried to add some more molecular sieves, not realizing that they were obviously too big. Instead of getting another funnel, I decided to lazily pour them in, which kind of resulted in a small spill. The idea behind adding the sieves was that hopefully they would absorb the remaining water over time and leave me with a more pure ethanol solution. After this, I decided to put away the ethanol in storage.